Matlab has a lot of tools devoted to working with arrays, and this is the first of several videos that will cover all the basics. An array is a rectangular table of numbers. Higher dimensional arrays are also possible, but I won't be going beyond 2 dimensions. An easy way to create an array is to type in some values between square brackets. You use spaces or commas to separate columns, and semicolons or new lines to separate rows. Notice that I never have to declare a variable to be an array. Matlab takes care of allocating and deallocating memory, and so on. This makes it easy to think at a high conceptual level. On the downside, it can introduce some potential subtle performance penalties, but we won't worry about the drawbacks for quite a while. An array with only one row could be called a row vector, and one with only column is a column vector. You don't have to do anything special to get a vector. It's just a consequence of the shape. Often we want an array, particularly a vector, that spans some range of values. For that, we have 2 complementary options. The first option is to use the colon operator. If I give 2 numbers separated by a colon, the implication is that I want an array of values starting at the first, increasing by 1, and ending before we get larger than the second number. The result is a row vector. You might wonder what you get if the starting value is bigger than the end value. Logically, this is a vector with no entries, and you do get back something called an empty matrix. You can construct an empty matrix directly when you need one, just by using square brackets with nothing in between them. Let's get back to the colon operator. If I want a step size of something other than +1, I use 2 colons and put the step in between. I get a decreasing sequence by using a negative step size. So that's one way to create a linear range vector. The other is to use the command called linspace. In linspace, rather than supplying the step size, you specify how many entries you want the vector to have. The size command returns the number of rows and columns in an array. These are sometimes called the dimensions of the array. Some languages, notably Python, refer to this as the shape of the array, so there is potential for confusion. We can transform row vectors to column vectors and vice versa by using the transpose operator, which I enter with a dot quote. The complicated truth is that sometimes the row-column shape doesn't matter and sometimes it does. There's no uniform rule to cover all cases. You can transpose non-vector arrays as well. The columns become the rows and vice versa. Also, the dimensions are swapped. We're still just getting started. In the next video, I'll explain how to build more complicated types of arrays.